Today we will solve a few interesting and important sums based on algebraic identities. To solve the first one, we will use the following identities. Now we will start with the given expression. So here x is our a if we follow the first identity, and 1 by x is our b. So as per that identity, it will be a minus b. So x minus 1 by x, and then a square means x square plus ab, then plus b square. So 1 by x square. X will cancel each other. So finally it will be x minus 1 by x, and then multiplied by x square plus 1 by x square, and then plus 1. So we need to find the values of x minus 1 by x and x square plus 1 by x square. Now we have another relationship, x to the power 4 plus 1 by x to the power 4, and that is equal to 119. So it can be further written as it is x square and then square of that plus 1 by x square and then square of that, and that is equal to 119. So it is in that form, a square plus b square. So it will fit either of these two identities, and we will see which one is more applicable. Now since in this factor we need to find, or we need to get the value of x square plus 1 by x square, so we will use the second identity. So as per the second identity, it will be x square plus 1 by x square means a plus b, and then whole square minus 2ab, so minus 2x square, and then here 1 by x square, and then that will be equal to 119. So it will be x square plus 1 by x square and then whole square, and it can be written as further this x square and this x square in the denominator will cancel each other. So minus 2 will go to the other side, and that 119 and plus 2, it will be 121, which is square of 11. So from here we can say that x square plus 1 by x square, that value will be equal to 11. Now this value we have already obtained, but still we need to find the value of x minus 1 by x, and for that we will be using the third identity. So at the end of the previous calculation, we have obtained that x square plus 1 by x square, and that is equal to 11. Now if we fit this with the third identity, a square plus b square, and that if we write as a minus b whole square in that format, then it will be x minus 1 by x whole square plus 2ab. So 2x and then multiplied by 1 by x, and that will be equal to 11. So this x and this x in the numerator and denominator will cancel each other. So further we can write 1 minus 1 by x whole square, that will be equal to how much? 11 and minus 2. Here we have plus 2 on the left side, so it will be 9. So we can further write as x minus 1 by x, that will be equal to 3. So we have already obtained x square plus 1 by x square, that value, and that is 11, and x minus 1 by x, that value is 3. Now we can easily put into this expression. So in place of x minus 1 by x, it will be 3, and then it will be x square plus 1 by x square is 11. So 11 plus 1, so it will be further 11 plus 1, 12. 12 multiplied by 3, that will be equal to 36. Now we will move on to the next sum. So here a plus b plus c, that value is given, which is 9, and ab plus bc plus ca, that value is also given, which is 26, and we need to find the value of aq plus bq plus cq minus 3abc. We already know this identity, and this can be further rewritten as, now here a plus b plus c, that value is given, so we know that value. ab plus bc plus ca, that value is also given, but only thing that we still is unknown to us is a square plus b square plus c square, and that we can find from the given information. We also know this identity, so by using this identity we can easily find the value of a square plus b square plus c square, because here a plus b plus c, this value is known to us, and here ab plus bc plus ca, that value is also known to us, so we can easily find that value. Now in place of a plus b plus c, we will be putting this value, so it will be 9 square minus 2, and this value is 26. So it will be 81 minus 52, so it will be 29. So if we now go back to our previous calculation, then in place of a plus b plus c, we can put the value 9, and then we have here a square plus b square plus c square, and that value we have already calculated, which is 29, and then minus a b plus bc plus ca, and that value is 26, that is given. So finally it will be 9, and 29 minus 26 3, so it will be finally 27. Now the next sum, again in the numerator we have a format of aq plus bq plus cq, and in the denominator again we have that format aq plus bq plus cq. Now let's assume that a square minus b square is equal to x, b square minus c square that is equal to y, and c square minus a square that is equal to z. So whatever expression we have in the numerator, that can be written as xq plus yq plus zq, right? We know this identity that xq plus yq plus zq will be equal to 3xyz if x plus y plus z that is equal to 0. So let's see that whether this given expression fits in that identity or not. Here x is what? X is a square minus b square, so that is x, and then what is y? Y is b square minus c square, so plus y, and plus z. Z is c square minus a square. Now if we simplify this, we can see here plus b square minus b square plus a square minus a square and plus c square minus c square will cancel each other, so the final value will be 0. That means in the given expression, the x plus y plus z, that format, that value is coming as 0. So xq plus yq plus zq, what we have in the numerator, that will be finally equal to, 3xyz, means 3 in place of x it will be a square minus b square, y means b square minus c square, and then z. And similarly in the denominator also we have the same format, xq plus yq plus zq. Here a minus b will be our new x, b minus c will be new y, and c minus a will be new z. So now if we evaluate x plus y plus z, then it will be a minus b plus b minus c, and then plus c minus a. So finally again it will be 0, and whatever expression we have in the denominator in the form of xq plus yq plus zq, that value again will be 3xyz. So 3x means a minus b, and then y means b minus c, and z means c minus a. So these two expression now we will be using in our actual expression or given expression. So the value of xq plus yq plus zq that we have in the numerator, that we have already found out, and that value is this, and that we have written. And the value of again the format xq plus yq plus zq, and that value again we have found out, and this is the value. So accordingly we have written in the numerator and denominator, and again here a square minus b square, so we will again expand as per that identity. So it will be 3 a plus b, a minus b, and accordingly b square minus c square, so that will be written, and the last term or last factor also, so that will be c plus a, and c minus a, and then we will write the what we have in the denominator. So here what we can see, 3 and 3 in the numerator and denominator will cancel each other, a minus b, a minus b, b minus c, b minus c, c minus a, c minus a, so they will cancel each other. So what finally will remain in that expression is a plus b, then b plus c, and then c plus a. So this will be our simplified answer. Now in this expression we need to evaluate. So here we need to factorize the given expression. So what we can see here is we have 2 root q aq. So 2 means root 2 square. So here we can say we have this root 2 thrice in the first term. So that can be written as root 2a and then whole cube. So a cube and root 2 cube means 2 root 2. Similarly, the second term can be written as root 3b and then whole cube. And the third term is c cube. So it is in the format a cube plus b cube plus c cube. and now we have some this term where we have some constant value and also abc. So the thing that comes in our minds, if we can fit this expression in that identity, aq plus bq plus cq minus 3abc, whether we can do or not. If we can, then that will ease our simplification. So 3 root 6, let's try to fit in that identity. So here already we have xq plus yq plus zq, those terms, and minus 3 xyz we need to have, and that we are trying to fit. So here 3, we are writing this, and then in place of x is what, root 2a. So root 2a, then y is root 3b, so that we have written, and then z is c. Now if we multiply all these 4 terms, then what value we will be getting? Here 3 and root 2 and multiplied by root 3, that will be 3 root 6, and here it will be abc. So 3 root 6 abc, this value we are getting by applying this identity. So the given expression is matching or is fitting with this identity. So what we can write is x plus y plus z. So our x is root 2a, y is root 3b, and z is c. So x plus y plus z, and then we will be having x square, so root 2a and then whole square, so it will be 2a square, then b square, or y square means root 3b then whole square, so it will be 3b square, and then z is direct c, and that is c square, minus xy. So x means root 2a, y means root 3b, minus yz, so root 3b and then multiplied by c, and then minus c zx, so it will be c, and x is root 2a. So if we simplify further, then it will be, now the next and last sum of this class, x cube minus 3a square plus 3x plus 7 is given in terms of product of two factors, and from there we need to find the values of a, b and c, or rather the summation of a, b and c. So what we can do is we can rewrite the terms on the left side of this expression like x cube minus 3x square, 3x, then minus 1 plus 8, and the left side we can write this way, x cube minus 3x square, then multiplied by 1, then plus 3x, and then we can write multiplied by 1 square, then minus 1 can be written as 1 cube, and then plus 8, and again the terms that we have on the right hand side. We know this identity, a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. Now if we look into this, what we have on the left side here, x cube, so x is directly mapped with a, then minus 3x square, and then 1. So here 1 is mapped with b, so it is 3a square b in that format, then plus 3, again x, in place of x we can imagine a, so 3ab square, because here b is 1, so 3ab square minus b cube. So the first 4 terms can be further written as a minus b then whole cube in that format. So it will be x minus 1 and then whole cube, and then we have 8 can be written as 2 cube, right? And then the factors that we have on the right side. So from the left side again it will fit that identity, a cube plus b cube, so it will be a plus b, because here x minus 1 itself is our a and b is 2, so a plus b, and then a square minus ab, and then plus b square, so that we have on the left side. And then let's complete the right hand side. So again if we calculate or simplify further, then from the left side we will have x minus 1 plus 2, so it will be x plus 1, and in the second term or second factor we will have x square minus 2x then plus 1. From here it will be minus 2x then plus 2, and then we will have plus 4. So here it will be x square, then minus 2x, it will be minus 4x, and the constant term will be 4 plus 2 plus 1, it will be 7. Now if we compare both the sides, so on both the sides we have x plus 1, that factor, and the second factor on the left side it is x square minus 4x plus 7, and on the right side is ax square plus bx plus c. So if we compare the coefficients of the second factor of both the sides, then we can write here that a will be equal to 1 because the coefficient of x square is 1 here. So a will be mapped with 1. Then b will be equal to minus 4. Here b, the coefficient of x is b, and here the coefficient of x is minus 4, and the value of c will be 7. So now if we evaluate or calculate a plus b plus c, then it will be 1 minus 4 plus 7. So finally it will be 8 minus 4, and that will be 4 only. So I hope this class was meaningful and helpful for you. With that hope, I end today's class. Take care and stay safe. Thank you.